So guys, write down the heading: charging of a parallel plate capacitor using a battery. Now, guys, tell me what happens when you have a parallel plate capacitor and you start charging that capacitor with the help of what do you mean by charging a capacitor? Giving charge to a capacitor, right?
Yeah.
So suppose, guys, you have a capacitor and you have connected this capacitor across a battery, and the potential difference across the terminals of the battery is V. The capacitance of this is C, है ना? Capacitance of the parallel plate capacitor is C. Can anyone tell me what will be the charge on this capacitor? See what will happen over here. First of all, guys, can you see over here? This battery has connected. We have connected. Ah. So, see, guys, we have connected this battery to this terminal, right or not? Hello.
Yes, sir.
So,
Seconds. Just 8 seconds. Ah. So, as you have connected a battery across this terminal, what would this battery do? This battery will try to do what? This battery will flow electrons from this particular thing, right?
yeah.
Because of this battery, now can you see the battery? The negative is over here, the positive over here. So the flow of electrons will take place from negative to positive, right or not?
Yeah. Yes, sir.
So what will happen over here? Uh, uh, do you remember this particular thing when we talk about battery? Battery, what is the direction of? Do you remember the resistance wala part in 10th grade we have studied? Can anyone tell me what will be the direction of current? The direction of
Positive.
current
Positive to
was
negative, right?
positive to negative, right?
Mm.
Whereas the direction of
Yes, sir.
electrons was from.
Negative to positive.
So
Negative
please
to
remember
zero.
the directions of electron was from negative to positive
Positive.
outside the battery, right?
Yes, sir.
है ना? तो ये याद रखना. So when you connect this with a battery, what happens? Certain positive charge gets created over the this plate. This plate becomes at higher potential, and this plate becomes at lower potential due to a certain potential difference gets created across the parallel plates, right or wrong?
Mm. Yes,
So
sir.
Yes.
when we connect a battery across the plates of capacitor, a potential difference between the plates is created because of the flow of electrons across the circuit. The plate with the positive charge is at higher potential, whereas the plate with negative charge is at lower potential. When we connect a battery across the plates of a capacitor, a potential difference between the plates gets created because of which the flow of electrons across the. Is this clear, guys? Are you reading this whole thing?
Yes, sir.
Yes,
What
sir.
will be the potential difference across the capacitor? becomes VA minus V.
VB.
Okay. Up initially, this potential difference across the plates is less than the voltage across the battery, right?
Yeah.
Initially, the potential difference across the plates is lesser. एक second. So initially, the potential difference across the capacitor plates is less than the voltage across the battery, due to which charges keep on flowing. And more charge gets accumulated. So due to which the charges keep on flowing between the plates and more charge gets accumulated on the plates of the capacitor. Is this clear, guys? So can you see this story, guys? Basically, the what happens, due to the flow, due to the battery initially, what happens due to battery does some work in moving the electrons from the positive to the negative plate, due to which the positive plate A gets the positive charge, right? Yes or no? So basically, this battery is responsible for creating a potential difference across the plates, due to which electrons they start flowing from the positive plate and going to the negative plate. That is why the charge over here it is positive and charge over here it is negative, because for the electrons will be flowing from here to here like this. Is this clear? I told you, electron always flows from the positive to negative, negative to positive outside the circuit, right? It's the same thing as this. The electrons will start flowing from here and it will go to this terminal of the battery, and this will get the negative charge and this will get the positive charge. Is this clear, guys? So what happens till the time the potential difference across this plate doesn't become equal to the potential across the battery, the charge on it keeps on increasing at one particular steady state, we call it.
Then what if we connect the battery in the opposite way?
So the polarity of the battery will change. The plate B will get a positive charge and plate A will get a negative charge. That's it. Only the polarity of the charges is reversed. Nothing else. At steady state, that implies after a very long time, the capacitor will become fully charged and the potential difference across the plates will become equal to the potential across the voltage across the battery. Is this clear, guys? So always remember, whenever you have any capacitor like this and you have any battery like this, and when you write like this over here, no? So let's say Q plus Q and minus Q, right? And you write it like this, no? Q equals to C into V. Hello?
Yes, sir.
When you write
Yes,
it
sir.
like this, no, this Q equals to C into V. Q is basically the charge across the capacitor. V is the voltage of the battery. You write it like this. Actually, it is always VA minus VB, potential difference across its plate. But क्योंकि at steady state, VA minus VB becomes equal to the
Voltage.
voltage across the battery. So hence Q equals to CV. Please remember, note this one is only for a single isolated. We'll see combination what exactly happens in the combination. Okay? Is this clear? Do you remember this is just symmetric to Ohm's law? Note, and this is analogous to Ohm's law in current electricity. Okay. Okay, guys. It's just like Ohm's law, will be using this.
So,
Yes.
can you explain the last part? Q is equal to CV again.
Q is equal to CV is the definition. Do you remember? Capacitance was basically charged upon VA minus VB by the definition of capacitance, right? Basically, here in this
Yeah.
case, VA minus VB becomes equal to the potential voltage across the battery. That's why Q is equal to CV. Okay?
Oh, here we're just substituting it, right?
Yes. Here is
That
just substitute.
formula.
Yes. But we will
Yes, sir.
do numericals also based on this. Don't worry. Okay? We'll do series and parallel combination of capacitors. Shall we start?
So, why did you draw the resistor diagram?
Why did you get?
I wasn't there. The in the first diagram, right?
Uh-huh.
Next to it, you do the resistor thing. I
Because
wasn't
I
there for that.
told
Why
you know
did
this particular thing when you have a resistor over here, so the current flows from positive to negative, whereas the electron flows from
yes,
negative to positive.
positive?
So here also the same thing. Electrons also can you see over here the same way battery is connected, but the in case of resistor are given a capacitor.
Yeah,
What was the direction of flow of electrons, clockwise or anti-clockwise?
anti-clockwise.
The electrons were basically flowing anti-clockwise like this. This was the flow of electrons. Here also the electrons will flow like this. So that is
Okay.
why the electrons, when they get coming from this surface, can you see when electrons leave this becomes positively charged, and when electrons goes over here, it becomes negatively charged. Basically, I
Okay.
told you it's analogous to this.
Yes, sir.
Okay. So this was charging of a capacitor. Please remember this charge is at the steady state. Steady state is basically when you keep the capacitor long, to charge long enough, then it becomes this thing. Is this clear? Completely clear. Shall we start the combination series parallel
Yes, sir.
Yes, sir.
combination of capacitors? Does someone remember combination of resistors series parallel?
Yeah, series and parallel.
Can anyone tell me the definition of series combination?
It's like the total resistance is like the sum of the individual resistances of the resistors that are connected.
But when do you say the two resistors or capacitors or any other elements are connected in series?
End-to-end
End to
connection.
end
Close
connection.
both
Do you
Ah,
remember
resistors.
end to end connection? So suppose there are three capacitors which are connected to a battery. So what will happen? Let's say this capacitor is C1, C2 and C3. Three capacitors C1, C2, C3 are connected in series. Please remember, in series, everything is connected end to end connection across the same branch. For example, in this diagram, in this electric circuit which I have given in the question, how many branches are there? Only one branch is there, no? Can you see only one loop is there? A single wire
yes.
which is having everything in series. Can you see the end of this is connected to this, the end of this is connected to this, the end of this is connected to this, end of this is connected to end of this. Are you getting my point? So battery C1, C2, C3, everything is in series with each other, right? Yes or no, guys?
Yes, sir.
Yes, sir.
Okay. So here in this case, what did we do? We connected three different capacitors C1, C2, C3 in series with a battery. the battery. Now, what was happening, guys, when a single capacitor was connected across the ends of a battery, then at steady state, whatever was the terminal across the battery was across the capacitor, right?
Mm.
But what will happen if you apply a combination? When you have a combination of resistors, then what will happen? The potential across this battery will divide into three different things: V1, V2, and V3. In series, what divides? Do you remember? In series, what divides?
The voltage.
The voltage or the potential difference divides. Whereas what remains same?
Or
Current.
current.
The current remains same. So in this case, not the current, what will remain same? The
Charge.
So basically, what will you do? You'll flow a charge Q through this battery. When this charge Q will flow through this battery, what will happen? It will charge this as plus Q and this as minus Q. See this very carefully. Then after minus Q, again plus Q, minus Q, again plus Q, minus Q, and then this minus Q, the charge will again, the charge Q will return again back to the battery. Is this
Mm.
clear? So
Yes.
थोड़ा सा ध्यान रखना.
So,
Basically, it will keep the charges on every capacitor will be the same. Plus Q minus Q, plus Q minus Q. Because in series, charge remains same. Every capacitor. Is this clear? Guys, is this clear?
Yes, sir.
Yes, sir.
so
ठीक है. चलो right till here. फिर उसके बाद हम start करते हैं आगे. Now, since the potential difference of the battery was dividing across the phase, can I say V equals to V1 and V2? पानी दे दे. हाँ? कैमरा चालू है क्या तेरा? Yes, guys, whenever you're done.
Done, sir.
Now, see, guys, what basically will you do? If the potential is, do you remember this current also, in the resistors also, you grouped all these resistors into a single resistor of effective resistance, right? The same
yeah.
thing you do
Yes,
over
sir.
here, and you'll say the effective capacitance is basically in series combination is how much? CS, right? Same charge plus Q minus Q, same battery plus minus. So remember this, basically you group all these three into one particular capacitors and you write then Q is equal to C Q by, right? So this will be Q by CS is Q by V1 plus Q by V2. And from here 1 by 2 factor. Is this clear? So basically, can you see in the series of capacitance, you use the opposite formula of for resistance, right?
Resistance.
Yeah.
The one which you use for parallel in resistance, you are using for series over here. Okay. Hello, guys.
Yes, sir.
Now, this is the effective capacitance. How do you calculate the net charge coming out of the battery? It will be equals to what?
V into CS, like the total.
C net into, so what is C? V is the net, V is basically the battery across which charge was coming, and net is basically what? The net capacitance. It's not necessary only series combination is there. This is the common formula, so we use this. Okay. Hello.
Yes, sir.
Yes, sir.
This is the charge. ऐसे तो it's this trick is not the important division of voltage, but still I'll give you. By the way, this is the trick. Sorry. So suppose, guys, there are two capacitors which are there in series. And they are connected in series. Yes, two. Guys, just give me 2 minutes, huh? I'll be back. Yes, hello, guys. So now see over here, guys. Who was this mic? Right. Guys, just 2 minutes. Let me see who was this mic guy. Anyways, done it. So division of voltage across two capacitors. Now see, guys, there are two capacitors. Yes. Can anyone tell me what is the effective capacitance of the two systems? What is the net capacitance of the whole system?
1 by CS equal
1
to
by
1 by
C1
C1
plus.
plus 1 by C2.
1 by Cs will be equals to 1 by C1 plus C1 by C2. So can you see from here the net capacitance will be equals to C1 C2 upon C1 plus C2? Yes or no?
Yes, sir.
So remember
Yes.
this, see the multiplication upon the product upon the sum. C1 C2 upon C1 plus C2. So what's your C1 now? Can anyone tell me what will be the net charge coming out of the battery? What will be the net charge coming out of the battery? It will be net
C1
multiplied.
C2 by C1 plus
Yes,
C2 into V.
C1 C2 upon C1 plus C2 into V. Will this be the net charge? Yes or no?
Yes, sir.
So can anyone tell me what will be the potential difference across this capacitor V1 and across this capacitor V2? Can you see this V was basically dividing into V1 and V2? Yes.
Yeah.
Anyone tell me what will
Yes,
be the
sir.
charge on plus C1 Q? This C1 will be plus Q minus Q on the plates. Acha, by the way, even if the charge on the plates is plus Q minus Q, you will still say the charge on this capacitor C1 is Q. Why will not give any potential to Q? Can you see? You have both positive and negative plates of charge Q. So that's why you just say, okay, I have a capacitance of C1 with a charge Q. I have a capacitance C2 with a charge Q. Are you getting my point? You don't say
Yes,
plus
sir.
Q minus Q.
Yes.
Okay. So V1 will be equals to Q by C1 and V2 will be equals to Q by C2, right? So when I divide this thing by C2, can you see? Charge on both of them was this. This divided by C1 will be equals to C2 upon C1 plus C2 into V. And V2 is basically C1 upon C2 into V. Is this clear?
Yes, sir.
Please remember this thing is very important. So if someone tells you to, suppose I'll give you example, it's a clear only. So if suppose there are two, this thing. Let's say this is 3 microfarad and this is 5 microfarad. And someone tells you to find out what is the potential difference across them if they are connected to a, let's say, a 16-volt battery. Yes. How will you do it? Can you say V1 is basically C2 upon C1 plus C2? So if I want to calculate what is the potential difference across 3 microfarad, so that will be equals to 5 upon C plus 5 into what is the total? 60. Are you getting my point?
Mm.
So
Yes, sir.
directly you will do this. If someone tell you what is the potential difference
And
across 5 microfarad, 3 upon 3 plus 5 into, is this clear? Is
yes,
this
sir.
clear, guys? So remember this, this is how you will solve the problems based on series combination of this. Any doubt in here? Guys, shall we move on? Shall we move to the parallel
Yes,
combination?
sir.
Yes, sir.
Yes, sir.
So the second is basically the parallel combination. When do you say two capacitors or resistors are connected across parallel combination? So, two or more capacitors or any other element are said to be in parallel when they are connected between two fixed points.
So what is that after any other?
Elements, any other element of the electric circuit. मतलब कुछ भी हो सकता है. It can be capacitor, it can be resistor, it can be battery, it can be anything. Okay. So between two fixed points having certain potential difference between them. So basically between two points which are having certain potential difference. So guys, shall I start writing? Done with the definition. So always remember that whenever two elements of the circuit, it can be capacitor, it can be resistor, it can be inductor, it can be a battery, it can be anything. Whenever two or more types of these elements, they are connected between parallel connect. They are connected between two fixed points having certain potential difference, then they are said to be parallel connect, right? For example, suppose I have three capacitors. So guys, can you see three capacitors C1, C2 and C3 having capacitance C1, C2, C3 are connected between, can you see these 2 points? This point and this. Yes or no? Hello?
Yes, sir.
So can you see this capacitor C1 is in between point A and B? Can you see? The positive plate of C1 will be connected to A and negative plate will be connected to B, right? Can you see again the positive plate connected to A, the negative plate connected to B? The positive plate connected to A and the negative plate connected to B. Are you getting my point, guys? Ayana? All the positive plates are connected to A. Hence, all of them are at same potential. Same goes with negative plates connected to B. So all of the plates which are connected to point B, can you see the negative plate connected to B, the negative plate connected to B, the negative plate connected to B? The same plates, all these plates will be at the same potential. So can you see all the positive plates are at one potential or the negative plates are at one potential? That implies same potential difference across every capacitor. Yes or no?
Yes.
So remember this. In parallel connection, whatever be the potential difference, and what is the potential difference by the way? That potential difference is VA minus VB.
BB.
In this case, VA minus VB is equal to the battery, right? VA minus VB is equal to the battery. Hello.
Yes, sir.
Yes, sir.
Yes, sir.
So VA minus VB is equal to battery in this case. Not necessary in every case. So how will we do it over here? So let's say the effective capacitance of this thing is CP, and this will be equal to plus minus V with the same amount of charge with the same amount of charge. So can you see this, guys? If a charge Q comes out from this, then charge Q will go over here, charge Q will go over here, and when it comes to point A, it will divide among three different Q1, Q2, and Q3.
Q3.
So what will be on the positive plate of Q1 capacitor? What charge will be there on Q1? It will be plus Q1 and minus Q1. Are you getting my point? Shall I draw it a little bit distinctive? So is this fine? You will be able to do it. Look at my calculator now. So here it will be plus Q1, here it will be plus Q2, and here it will be plus Q2. What about the charge over here? It will be minus Q3, minus Q2, minus. Is this clear, guys? Are you getting my point now? The charge on the individual
Yes, sir.
plates of capacitor. Okay. So basically, this is how you divide the charge. So can you see in this case, the potential difference is same. The charge is dividing. So always remember what is dividing in the case of parallel combination. The charge divides across the capacitors. Whereas this thing, potential difference remains same. So anyways, since Q is basically equal to Q1 plus Q2 plus Q3, and you can write this thing as CP into V should be equal to C1 into V plus C2 into V plus C3 into V. From here you will get CP is basically C1 plus C2 plus C2. So can you see the formula for resistance in series are applied in parallel in case of capacitance?
Capacitance.
है ना? So remember this. उल्टा formula लगता है. The formula for series for resistance are used in parallel in the case of capacitance. And मजा अभी तब आएगा when I'll combine series and this capacitance and resistance together, and that will be dealt under current electricity RC circuits. Or I can do it.
So,
Yes.
so can you please scroll a little up? Like a little more. A little more up.
Tell me where to stop.
Yeah, up, 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 up. Yeah, yeah. Thank you. Thank you, sir.
Okay. So done. Capacity. Hello. Again, guys, the current through the battery will be equal to what C net into the charge across the charge coming out of the battery will be C net into B, right? Again, there is a trick to divide charges in parallel. So basically, I'll give you a trick to in which you'll divide the charge, and it's not necessary only applied for two. It can be applied for three or four or whatever it is. So suppose there are three capacitors over here. This is C1, this is C2, and this is C3. What is the charge on C1? Let's say Q1. What is the charge on Q2? Let's say Q2. And what is the charge on Q3? Let's say Q3. This will be Q. Can anyone tell me what was the net capacitance of these three? The net capacitance was C1 plus C2 plus C3. Was this the net capacitance?
Yes, sir.
So what will be the charge which will be coming out of the battery?
C1 plus C2 plus C3 into V.
So the charge coming out of the battery will be C1 plus C2 plus C3 into V, right? Yes or no? Now?
Yes.
So this will be the net charge. Now we know this particular thing. V will be equal to Q by Q net upon C1 plus C2 plus C3. Yes or no? Can I write from this to this? Can I write this? Yes or no, guys? Can I write this?
Yes, sir.
Yes, sir.
After this, what will I do? After this, what will I do? If I want what is 1, it will be equal to C1 multiplied by C2 will be equal to C2 multiplied by C3 will be C3 multiplied by yes or no? From here, can I write C1 upon C1 into so Q1 is basically C1 upon C1 plus C2 plus C3 upon Q, right? Q2 will be equals to C2 upon C1 plus C2 plus C3 into. Can you see, guys? Similarly, Q3 as well. Okay. So direct proportion way you can just directly divide it. Example. Suppose there are two capacitors. This is 2 microfarad and this is 4 microfarad. And let's say a charge which is coming for 12 microcoulombs is coming across these two capacitors. Can you tell me what will be the charge on the individual plates? What will be the charge across here and what will be the charge across here? See, can you see Q1 will be equals to what? That capacitor across which the charge is flowing to Q1 and C1. So if you want to find out Q1, then this upon the sum multiplied by the total charge. So this will be 2 upon 6 multiplied by total. That will be 4 microcoulomb, right? So what we, on the positive plate it will be plus 4 microcoulomb and on the negative plate it will be minus 4 microcoulomb. Similarly, when you will calculate 4, it will be 4 upon 6 multiplied by 1. This will be. अभी थोड़ी इसकी practice करेंगे. We'll do much more practice for this thing so that you know it will be much more clear. It will become 8 microcoulomb and this will become minus 8 microcoulomb. Are you clear? Is this clear, guys? So basically, this is how you will divide the charge. Okay. Chalo, question. Let's start with the basic question. Yes, guys. The question is there are three capacitances given to you. One is 6 microfarad, one is 1 microfarad, and one is 2 microfarad. They are asking you find the net capacity. Can you say it's a combination of series and combination both? And you need to apply your brains,
Yes.
just like you did in grade 10 electricity. Same way. The net charge coming out. चलो शुरू हो जाओ. Everyone start. Yes, whenever done. Yes, can anyone tell me what is the net resistance, net capacitance of the system? Can you see that
0.5
one
microfarad.
0.5.
1 microfarad and 2 microfarad are in parallel? What is the net combination of these two?
3
3
microfarad.
microfarad. And then this 3 and this 6 is in series. It
In
will be 3
series.
multiplied by 6 upon 3 plus 6. That should be 2.
2 microfarad, right?
2 microfarad,
2
right?
Oh
microfarad.
yeah, sorry, 2 microfarad.
So 1 microfarad. 1 microfarad is in parallel with 2 microfarad, and the combination of these two is in series with 6 microfarad. Yes or no? Ayana. So
Yes.
this will be 3 microfarad in series with 2 microfarad. It will be equals to. Please remember, you don't have to do like this in your school exams. This is not how you'll do it in your school exams. You will see, you will solve accordingly. Since 1 microfarad and 2 microfarad are in parallel, so hence 3 microfarad. Now the combination of 1 microfarad and 2 microfarad is in series with 6 microfarad. Hence, are you getting my point, guys? Because we need to
Yes,
write
sir.
the whole thing
Yes,
in
sir.
school exams. That's the problem. Anyway, the net charge coming of the battery will be C net multiplied by V, which will be
12.
20 microcoulomb. Yes or no? So how much charge is coming out of the battery? 20 microcoulomb. Okay. So tell me what will be the charge on this plate of the capacitor? Yes, can anyone tell me what will be the charge on these plates? Can
It'll
you
be
say this
20.
plus
10.
20? No, no, not 10.
Oh, wait,
How?
sorry. 20, yeah.
So this
In
20 will
series.
come directly over here, and this will be plus 20 microcoulomb, and this will be minus 20 microcoulomb. After charging this capacitor, this charge will go in this direction. Now, can you say this 20 microcoulomb? It will divide among two different resistors. Can anyone
Yes,
tell
sir.
me what will be the this thing? I think this should be 20 by 3 and this should be 40 by 3. Tell me what will be the charge on individual capacitor.
It will be plus 20 by 3 and minus 20 by 3.
Yes, so this will be plus 20 by 3 microcoulomb. Can you see the same trick, guys? This one, Ayana. So always remember that trick will come in handy. And what will be the plus 40 by 3 microcoulomb, and this will be minus 40 by 3 microcoulomb. Is this clear, guys? Is this clear, guys?
Yes,
Yes,
sir.
sir.
So this is
Yes,
how you
sir.
divide current. And once you know how what is the charge across individual capacitor, you can easily find out the potential difference, right? What is the potential difference across this? What is the potential difference across this capacitor?
20 by 6.
See, yes. And what is 20 by 6? It's 10 by 3, right?
Yeah.
So basically, out of this 10 volt, 10 by 3 is on this capacitor. So the remaining 20 by 3 will be on this combination of this. Is this clear? So it's up to you, guys. But थोड़ा ratio proportion पे खेलना है ना? Chalo, I'll give you some more questions.
I understand the potential part. How do you find the potential?
Once you know the charges on individual, no? And
Yes, sir.
you know the charge on this capacitor. Do you know the charge on this capacitor? 40 by 3, 20 by 3, right?
Yes, sir.
So if you know Q1, Q2, Q3, you can calculate. You know C1, C2, C3. So Q1 is equals to C1 multiplied by V1. Q2 equals to C2 multiplied by V2, and Q3 equals to C3 multiplied by V3. So can you see V3 can be find out by just by dividing the charge with the capacitance? है ना?
Yes, sir.
So
Okay,
charge
sir.
divided by 6, so 20 by 6, 20 by 3 divided by 1, 40 by 3 divided by 2. Are you getting my point? So D part can be done easily. Easily. Is this clear? I'll give you question. चलो guys, question करो. Find out the net capacitance. Or shall I give you one this type of question? Suppose guys, can you see a connection like this? So this is let's say 4 microfarad. This is also 4 microfarad. This is 6 microfarad, and T microfarad. Find the net capacitance across AV. है ना? Find net capacitance. Sita,
Yes, sir.
इतना late
Because it just ended. And I
because the
just,
what?
it just ended.
The career session.
Sorry? Yeah, the
What?
career session just ended.
The career session, right?
Yeah.
चलो ठीक है कोई बात नहीं. So by the way, I am recording the lecture, so I'll be sending you the recorded lecture notes. In the previous lecture also I recorded, but the point is, this Webex has some issues. It's like I'm doing this experiment today itself as well. It's like when after opening the OneNote, then I start recording, then it will record perfectly fine. And if it's like if I record on the main screen, then it will just keep on recording the main screen. It will not record anything which I share. This thing happened once or twice already with me, so we are trying to eradicate that one. Anyways, so how will you find out the net resistance? Can you see over here, guys? Can you see over here these two resistances? Can you see these two resistances, guys?
Yes, sir.
What are they
Yes, sir.
connected in? How are they connected in?
Series.
What about this 6 microfarad and this 6 microfarad?
Series.
Okay,
Series.
so 6
Series.
microfarad, 6 over 4 series, and this is in parallel with all three of them, right? Can you see? This
Yes, sir.
combination will be across AB, this will be across AB, and this will be across AB. Basically, what will be the final answer? The final answer will be there are three resistances across this net. Can anyone tell me what will be those resistances? It will be the combination of 6 and 6 in parallel. What will be the combination of 6 and 6 in parallel?
3.
3.
3 microfarad.
4 and 4 in parallel?
2
2.
4.
microfarad.
Yeah, 2 microfarad.
2 microfarad.
So,
The each one wala?
limit
Each
like
wala is how
6.
much? 3 microfarad.
so
3.
So now
yeah,
what will be the net?
8
8.
microfarad.
That is the answer. Is this clear, guys?
Yes, sir.
So,
Yes, sir.
Yes, tell me.
in the previous question, any idea of what V1, V2, and V3 is?
V1 will be 20 by 6. This will be 20 by 6 volts. This will be 20 by 3 volts. And this will be 40 by 3. No, this will also be 20 by
20 by 3.
3. Can you see 20 by 6 is basically 10 by 3. So 10 by 3 volts,
So,
20 by 3 volts. So 10 by 3 plus 20 by 3 is basically 10. Okay?
okay, sir. Yes, sir. Thank you, sir.
No problem. So is this clear, guys? समझ में आ रहा है ये basically I can redraw this circuit as this. Next question. These questions are called as ladder questions. I think you will be able to solve these ladder questions. 6 microfarad, 6 microfarad are in series. This is 3 microfarad. This is 4 microfarad. And this is also 4 microfarad. But guys, I don't want you to calculate the potential difference, the net capacitance across point A and B over here. I want you to find out across A and B over here. Can you see?
Mm.
So basically, now find out the net capacitance across A and B. These are two different questions, है ना? Yes. How will you start this type of question? Can you see you have been asked in A and B? Can anyone tell me which are in series, which are in parallel with each other? Which resistors are in series, which are in parallel? How will you start solving this?
Resistor 6, 6, and 4 parallel to 8 and 4.
8 nahi, this is 3.
Okay, sorry, sir. 3, 3.
This is 3. So this 6, 6 and 4 are in
Series.
Parallel to 3.
Series.
6, 6
Okay, yeah,
and 4
series.
are in series and parallel to 3. Yes, sir?
Parallel to 3 and 4.
Parallel to
Parallel
3.
to 3 and 4. Wrong. First of all,
Like what?
wrong. First of all, always never judge directly which is in series, which is in parallel. First thing first, always mark the joints. Mark the joints. You can understand this is wire joint, this is a wire joint, this is a wire joint. Is this a wire joint? Is this
Which
a
one?
wire joint? Or is this just a wire bent?
It's a bend, yeah.
It's a bent wire, right? It's the same wire and just bent like this. Yes or no? So the first thing is to mark all the joints. Wherever 2 or more wires are meeting. Can you see one wire is this and second wire is this? Whenever 2 or more wires are meeting at one particular point, that point is basically called as a wire joint. So
Joint.
mark all the
Okay.
joint. है ना? Remember, for any question, this should be your ideal step. Once you're done with the joint, now can you see over here? This 6, they are connected directly to each other, right? Across the same branch.
Mm.
So can you see you will start from here. So tell me what will be the combination of 6 and 6? Acha, please
Series.
guys, have you note down the combination? Yes, ho gaya. So basically tell me 6 and 6 will be in series. So what will they become? What will be the circuit become? It will become something like this. A is over here, 4 microfarad over here, B is still over here, and this 3 microfarad still over here, this point still over here, and what was this was also 4 microfarad. But on combining these two together, 6 and 6, you get how much?
3.
So basically you will connect a 3 across just by, replace those two and, by a 3 across the same two points. Yes or no, guys?
Yes, sir.
Now basically after this, once you've done this, what will happen? Now this 3 and this 3 will be in
Are in parallel.
parallel across points A and let's name this as C. So across A and C they are in parallel, right?
Mm.
So what will be 3 and 3 in parallel?
6.
So this will become 6 microfarad, 4 microfarad and 4 microfarad. Will it become something like this? Now when you combine 3 ohm on 3 ohm, will this point C which was initially a joint, will it be a joint anymore? It will be just a single wire which will be passing from A like this. Yes or no? Yes or no, guys?
Yes, sir.
So now
Yes,
after
sir.
this, what? These two are in
Series.
series
Series.
and in parallel with the next one. So can you see the final answer would be something like. So can you see? I'm just redrawing the circuit again and again. What should be the combination of 6 and 4 in parallel? 6 into 4 upon 6 plus 4, which is basically 2.4, right? Yes or no, guys?
Yeah, 2.4.
Yes,
What is the
sir.
net resistance across A and B? This 4 plus this 2.4, which will be
6.4.
microfarad. Are you getting my point, guys? So always remember to mark the joints, and once you mark the joints, after that you will do the question. Is this clear?
Yes, sir.
Yes,
Great.
sir.
Now question type, ladder question. So suppose this is 2 microfarad and this is let's name this 3 microfarad and this is 6 microfarad. This is 1 microfarad. This is 1 microfarad. This is 1 microfarad. This is now again the question is find the net resistance across A and B. Why are these questions called as ladder questions? Because the circuit look like ladder, right?
Yeah.
That's why. So how will we do it? And these type of questions will come again in current electricity. I'm trying to cover these questions here itself. Over there, I will give it as a homework. Okay? Hello?
So your
Sir,
voice is very feeble.
I'm
Yeah.
saying, I'm doing these type of questions in capacitive electricity. In current electricity
sir,
also.
again it's really low.
Still coming up? Hello?
Hello,
Sir,
sir,
Your
your
voice
voice is
is
still
very
low.
low. We can't hear you properly.
Can you hear me now? Hello, hello, hello.
Yeah,
Yeah.
yes, sir.
Okay.
Yes, sir.
So it's like these type of questions are basically called as ladder questions. Ladder questions will come in grade, the current electricity chapter itself. So over there, the same type of questions I'll give. I'll not solve them. I'll give those type of question as a homework because I'm telling you how to solve these type of questions in capacitor itself. We will not be wasting the time on the same exact question. Although the formula will be different, but how the approach will be same. Okay.
Okay, sir.
So now tell me, how exactly will you solve E and B? Now see over here,
So
guys. Yes,
start from the top. 6 and 3 will be in series.
with 6 and 3 will start from the here.
Yes,
Yes,
I'm sure.
always, always, always. You will never, if you start going from here, then your answer will always come wrong. Always start from this direction. So basically 6 microfarad, 3 microfarad. Can you see all the points? Guys, once you're done noting down the question, are you done noting down the question?
Yes,
Yes.
sir.
Yes, sir.
So can you tell me this part is in? What is this?
Series.
Series. So 6
Series.
and 3 series. Can anyone tell me what is 6 and 3 series?
So 2
2
microfarad.
This will
2
be
micro.
2 microfarad. So can I stop it? I can. Oh, wow. Nice. I like it. This was 6 microfarad. This was 1 microfarad. Basically, when you combine those two, you got how much? 2 mic. Right or wrong? Yes or no, guys?
Yes, sir.
Now this 1
Yes.
microfarad, can you see this point and this point? This 1 microfarad and 2 microfarad are connected between these two points.
Parallel.
Parallel connection. So basically these two will be parallel.
2
What will be the
microfarad.
effective? What will be the
3.
effective? So basically this will become 3. Right or wrong? So can you
Yes, sir.
see, guys, from here to here there was a decrease in one chain, one link of the unit, right?
Yes, sir.
So similarly, if you apply the same logic, can you see 6 3 parallel? Oh, sorry, 6 3
Yes.
series. 6 and 3 series will become 2. 2 and 1 parallel will become 3. Then 3 and 6 in series will become 2.
2,
2 and 1 in parallel will become 3. And 6 and
3,
3 in parallel in series will become how much? 2, so the final resistance CAB is 2 micro. Is this clear?
Yes, sir.
Hmm.
Next question. Next question, I'll give you cyclic ladder. Cyclic ladder, देखो. Cyclic ladder. Do you remember this question? Just did earlier. This question. Hello guys. This question is based on cyclic ladder, है ना? And you try to understand exactly what was the case. Suppose guys there is a hexagon. Can you see an hexagon, guys? Guys, can you see a hexagon?
Yes, sir.
Can you see the connection now? How exactly is the connection? All the vertices are connected as well as, all of them are connected with point A. A, D, A, C, A, B, A, F. है ना? All of them have a capacitor in between. I'll just draw. So, tell me. Yes, how will we deal with this question? How will we deal with this?
So we start from A and E.
Yes, we start from the capacitors between A and E. So first of all, what 2 and 2 will become in series, right?
So 1.
1, the final answer is 1.
No, final answer is not 1. I didn't get 1.
Oh, final answer is not 1. Final answer will be, final answer will be, final answer will be 2.
Capacitance
Huh?
between which 2 points do we have to find?
AB. Find the net resistance across A and B.
Is it 2? Final answer? Oh, sorry,
No.
not 2. 4. 4.
Yeah, the final answer is 4.
I got it, sir.
2 by 3 it will be 4. Anji, so how will you do it? First thing first. Yes, guys, how will you do it? First thing first. Yes, who would like to tell? Please, batao. Can you see these two resistances, these two capacitances
Are in series.
are in series? So what is the net resistance of these two? Have you drawn the
1.
question, guys?
1.
Yes.
Yes, sir.
So shall I start redrawing in the same question itself?
So you can start rubbing. Yeah.
So this 2 and 2 will become how much?
1.
1.
1.
1 microfarad. After that, what will happen?
Those 2
1 and
will
1
give you
will
a
become 2.
capacitance of
Are in
2.
parallel.
These 1 and 1 are in parallel, so it will become 1 plus 1.
2.
2.
It will become 2 microfarad. Yes or no? After that, what will happen? This 2 microfarad and this 2 microfarad. Can you see one link has been gone now?
Series.
One link gone. Yes or no?
Yes,
So can you
sir.
see 2 microfarad, 2 microfarad?
1.
Become
1.
1 again.
1 plus 1, 2 again.
2.
2 plus 2,
Plus 2. 1.
1.
1 plus
1 plus 1,
2.
2.
and 2 plus 2,
1.
1.
And 1 plus 2 is 3.
and
3.
the final answer is 3, not 4.
Sorry, sir. Calculation error. So I did it
Yeah.
mentally. So I was doing it mentally. So I went wrong. 2 plus 2. 1 plus 2.
So
Yeah.
the final answer across A and B will be 3. capacitance, 3 microfarad. Yes or no? So these
Yeah,
type
sure.
of questions, thoda say, they are pretty standard questions. Acha, I'll give you one more question. Ladder only. अच्छा ऐसे तो I don't have any proper मतलब data वाला question for ladder, but I think I can give you one. Yes, I can give you one. So suppose guys, hmm, uh, yes guys, can you see an infinite ladder now? Hello guys,
Yes, sir.
Yes.
can you see this whole circuit is extending till infinity? Can you see the whole circuit is extending till infinity, right?
Yes, sir.
Yes, sir.
So can anyone tell me what should be the effective capacitance of this whole component?
So we can just do 1 unit and find out, right?
We can just do what?
1 unit of the ladder.
हाँ मतलब your direction is correct, but what exactly will you do with that 1 unit? Tell me what exactly will you do with that 1 unit?
So you can find the net capacitance of that 1 unit, yeah.
Okay, so that will be repeated infinite times. Is you are you applying the same logic?
Yes, sir.
थोड़ा सा गलत हो जाएगा, it will be mathematically incorrect. But see over here. First thing first, let's say the net capacitance of this is how much? Okay. Hello.
Yes, sir.
Let's say the net capacitance across the whole A and B is C. Okay. Is this clear?
Yes, sir.
Yes,
Now
sir.
see this circuit very carefully. Na? If I cut this circuit from here, if I cut this circuit from here, can you see? If I cut this circuit from here, will it look like this? Yes, guys. Will it look like this? If I
Yes,
cut
sir.
the circuit from here, will it look like this? So basically the logic behind this is, when I cut it from here, can you see the whole unit was basically this only? If I cut it from here, did I make the same circuit as it was in the previous case? Can you see? A, B were 2 points, so can you see A dash, B dash? the same 1 microfarad first, then 1 microfarad, then 2 microfarad was over here, 2 microfarad, then 1 microfarad, 1, 2, 1, 2, 1, 2, 1. So basically, what I did conceptually, suppose infinity, if it's like an ocean, then I just took one mug of water from that ocean. Did it make any difference to the ocean?
No.
If I take one mug of water, or if I add one mug of water into the ocean, will it make any difference to the ocean? Are you getting my point? So basically, out of the infinity, I just took one unit. Okay, that it won't make any difference to the infinity. So what will happen? The remaining circuit, and you see the remaining circuit, this part, it will have a capacitance of C only. Still, it will have a capacitance of C, right?
Yeah.
So can you see from here? I can say there is a 2 microfarad capacitor, and with this point, there is a capacitor of capacitance C. And what is the net capacitance of the whole thing? C again. Are you getting my point?
Mm.
So please
Yeah.
remember, this becomes like this. And when this becomes like this, now this C and 2 are in
Series.
series. The C is in
Series.
series with 2, and the whole is in combination and is in parallel with 1, right?
1.
So can I say twice of C upon C plus 2 plus 1 is basically equal to 1. Can you see the net capacitance was also equals to C only, right? So I just equated C is equals to this. Can you see from here? Quadratic is getting formed. C square minus C minus 2 equals to 0. Yes or no? Yes? Done? Is this clear, guys?
Yes.
Yes, sir.
See.
Mm.
So could you explain the initial part,
So do we explain the initial, the concept part?
like like starting the first unit of capacitance? How do we consider it?
This unit. है ना? So
Yes.
basically what do? You when you see the circuit, it's like 1 microfarad was over here, 2 microfarad was over here, and this unit was getting repeated again and again, right?
Yes, sir.
So I just took one unit out of the circuit. Basically, I cut the circuit from this particular point.
Okay.
So when I cut it from this particular point, what just happened? The whole remaining thing, it was the similar as the previous one, right? Can you see it was 2 microfarad, 1 microfarad, 1 microfarad. First, you encountered 1 microfarad and then 2 microfarad. Can you see when you cut it from here? First, you encounter 1 microfarad and then 2 microfarad, then 1, 2, 1, 2, and so on till infinity. So basically, when you
Yes.
cut it from this particular axis, I get the same circuit as it was in the previous case. Why did I say the same circuit? Won't it be, sir, 1 unit less? But this was infinity. That's why when I take 1 unit out, it doesn't even affect the infinity, right?
Hmm.
So basically what I
Yes.
did, I assumed the whole circuit, initial circuit, to be C. So this whole thing, sorry, this whole thing became also C. So what I did, in place of the whole circuit, I replaced it by a C capacitor. Can you see when I connected this again, it became 2 microfarad and C was in series, and the combination of these two was in parallel with 1 microfarad. So basically
So
the net,
isn't this something like an assumption?
yes, no, it's not an, do you remember, these type of questions in maths? If y is equals to under root of x plus under root of x plus under root of x plus till infinity. Have you seen these type of questions in maths?
Yes,
Hmm.
sir.
So basically, what do? If this is
We
equals to
assume
this,
the whole thing is y
so
and then we take
this,
x plus under root y.
yes, exactly. So basically, you will assume this whole thing is what? Y, right? So y will be under root of x plus y, and then it will be equals to y square is equals to x plus y. Are you getting my point? This is some type of question which you do in maths, right?
Hmm.
So out of what we do is basically we take out 1 unit. Will it make any difference? So can you see we took out 1 unit under root of x plus something. That something was y. We wrote it as y. So it's the same concept
Okay.
but applied in physics. Yes, tell me.
Can we do it mentally also? Like the same
Yes,
unit
you
is
can do it
repeating.
mentally, but the point is you can't calculate till infinite. Whenever it is
No,
too
not
long,
infinite. Like, see, if we simplify the series, then we get the same, like almost in parallel. So if we simplify, we're getting like the same thing again and again.
how are you
So can
simplifying?
we just solve
How
one
are you
unit?
simplifying?
So 2 and 1 is in parallel.
Wrong.
No, series.
Wrong. They
What?
are neither in parallel nor in series. If you are
Why?
talking about these two and this one, these two and this one, they are neither in series, neither in parallel. Because for being in series, they should be connected end to end. And see, can you see
Okay.
this was in this branch, 1 microfarad was in this branch, and 2 microfarad is in this branch. So
Hmm.
both have different, both are in different branches. They are not in the same branch. Hence the potential
Okay.
difference in the charge will be different. So they are not in series, and since they are not connected between the two same fixed points, hence they are not in parallel either.
Okay. So in
What
these
about the
questions,
1
they don't ask us to
microfarad in
calculate
like on
charge.
the right side?
With this and this,
Yeah,
no,
that's also
still
the
not,
like
still
same
not,
way.
because for this 1 microfarad to be solved, this 1 microfarad and this whole thing, I'll just draw it.
Has to be solved. Yeah.
This 1 microfarad and this whole thing is in parallel.
Okay.
This 1 microfarad and this whole thing is in parallel. This 1 microfarad and this whole thing is in parallel. Are you getting my point?
Yes, sir.
So basically, it's like that. So it's a little bit difficult circuits, but they are very common. That's why I told you how exactly you deal with these type of circuits. Okay, you take 1 unit out, and don't worry, we'll do some more questions on resistors as well. So, anyways, then it's just a quadratic form. So y square minus y is equal to x. Are you getting my point?
Such question, they won't ask us to find charge and all.
No, no, no. They will not. They will just give you normal capacitance find out questions, or they may ask you questions like this. चलो एक question I'll give you. एक question. This question was asked in some competitive exam. Although this question will make sense once I'll teach you SS method, but SS method यहाँ पे अभी नहीं अभी you don't have the tools necessary tools to solve the problem, this type of problem. Once I'll teach you SS method, then you'll be able to solve this very easily. But anyways, is this question clear, guys? Is these type of question, ladder question clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Next type of question, or you can write down.
So we don't have any other class today.
You have, no? Oh, 16:38. Oh, sorry. My bad. Chalo, we'll see you again in the next class, guys. Sorry. I took the time for your break. I'm sorry.
No problem, sir.
Chalo, thank you very much, guys. We'll see you
Thank you,
again in the
sir.
next class.
Thank you,
Yes,
sir.
sir.
Okay.
Thank you.
So